Dark matter. Most people have heard the words, and you may even be familiar with it. It's mysterious, and in reality, not a lot is known, but we do know it's out there. So, what is it? Since not a lot is known, we start the process of explaining dark matter by pointing out what it is not. For starters, dark matter is not visible matter, which can probably be guessed by the name. Unlike dark matter, visible matter emits light, whether X-ray, infrared, or UV, and is thus detectable. As you can imagine, this is what has made dark matter so difficult to pinpoint. Dark matter is also not normal or baryonic matter. In other words, it is not constituted of protons, neutrons, or electrons, which consist of three quarks. Some theories suggest baryonic matter makes up a portion of dark matter. However, this is not the prevailing viewpoint. We also know dark matter is not some undetectable form of antimatter. What happens when antimatter and matter meet is an annihilation that produces unique gamma rays, and these gamma rays are not present with dark matter. Lastly, dark matter is not simply large black holes. This is assumed primarily due to the way dark matter affects the matter and light around it. Black holes are central objects that cause stars and other celestial bodies to orbit at a very rapid rate around them. Dark matter is thought to surround galaxies because it causes the matter further from the center of a galaxy to rotate just as fast as the matter near the center. Additionally, dark matter has been detected by seeing that the light passing through and around it is distorted due to its gravitational pull. This process is called gravitational lensing and has not yet been observed near black holes. If dark matter is not visible, how did we know it was there in the first place? Shortly after it was discovered that there were other galaxies out there besides the Milky Way, a Caltech professor named Fritz Zwicky was analyzing the Coma Galaxy cluster. Zwicky calculated, based on the movements of the galaxies, how much mass needed to be present. When comparing it to the actual visible amount of mass present, he found a large discrepancy. In fact, there needed to be 160 times more visible illuminated mass to satisfy his calculations. Since the cluster was stable, there had to be some unseen mass to account for this. As a result, he coined the term dark matter to explain this invisible phenomenon. Some years later, Vera Rubin conducted experiments in which she measured the rotational curve of galaxies similar to the Milky Way. What she found was the rotational velocity of the galaxies stayed the same as the distance from the center increased. The only explanation for these findings was some sort of invisible mass surrounding the galaxy. While it is unknown exactly what dark matter is, there are a few possibilities as to what kind of particles it is made of. One possibility is massive compact halo objects, or MACHOs. These range in size from small neutron stars to supermassive black holes, and are the result of supernovas. They are made of normal matter, but can also be dark when isolated. However, since MACHOs come from supernovas, they are not very abundant, unlike dark matter. Supernovas also emit high levels of energy and heavy elements, which are not detected in areas where dark matter is expected to be. A second leading theory on the composition of dark matter is weakly interacting massive particles, or WIMPs. WIMPs are subatomic particles that are not made of normal matter. In this sense, the term massive simply refers to particles having mass. WIMPs are able to travel through ordinary matter with no interaction, which is why they are called weakly interacting. WIMPs with the highest possibility of making up dark matter include neutrinos, axions, and neutralinos. However, neutrinos simply are not massive enough to be components of dark matter, and axions and neutralinos have yet to be observed. So what we have here is an unknown invisible mass that makes up about 85% of all matter and 27% of the entire universe, and only interacts with normal matter through gravitational force. It seems like it may be a while before we find out exactly what dark matter is, but there is some research being conducted. In a recent article from Caltech, a nearby dwarf galaxy called Triangulum 2 was found to have the highest calculated ratio of dark matter to luminous matter, making it an ideal candidate for possibly tracking the dark matter. Another study using NASA's Chandra X-ray Observatory and Hubble Space Telescope analyzed 72 galaxy cluster collisions in an effort to see how dark matter interacts with itself. The findings have allowed astronomers to map the distribution of dark matter using gravitational lensing and help narrow down the possibilities of what dark matter is. In a study done just last year, a mysterious X-ray signal was received that is possibly the result of the decay of sterile neutrinos. Even though the chances of this being a product of dark matter is pretty low, the data is being analyzed for the possibility that sterile neutrinos make up dark matter. Not much is known yet about dark matter besides the fact that it exists, it is unseen, and it is abundant. Knowing what it is and what it is composed of can help us unlock the history of the universe by giving us a snapshot of it just milliseconds after the Big Bang. Until then, dark matter remains one of the biggest unanswered questions left for science to tackle.